The Hubble Space Telescope, often referred to as HST or Hubble, is a space telescope that was launched into low Earth orbit in 1990 and remains in operation. It was not the first space telescope, but it is one of the largest and most versatile, renowned as a vital research tool and as a public relations boon for astronomy. The Hubble telescope is named after astronomer Edwin Hubble and is one of NASA's great observatories. The Space Telescope Science Institute, STSCI, selects Hubble's targets and processes the resulting data, while the Goddard Space Flight Center, GSFC, controls the spacecraft. Hubble features a 2.4-meter mirror, and its 5 main instruments observe in the ultraviolet, visible, and near-infrared regions of the electromagnetic spectrum. Hubble's orbit outside the distortion of Earth's atmosphere allows it to capture extremely high-resolution images with substantially lower background light than ground-based telescopes. It has recorded some of the most detailed visible light images, allowing a deep view into space. Many Hubble observations have led to breakthroughs in astrophysics, such as determining the rate of expansion of the universe. Space telescopes were proposed as early as 1923, and the Hubble telescope was funded and built in the 1970s by the United States Space Agency NASA, with contributions from the European Space Agency. Its intended launch was in 1983, but the project was beset by technical delays, budget problems, and the 1986 Challenger disaster. Hubble was finally launched in 1990, but its main mirror had been ground incorrectly, resulting in spherical aberration that compromised the telescope's capabilities. The optics were corrected to their intended quality by a servicing mission in 1993. Hubble is the only telescope designed to be maintained in space by astronauts. 5 space shuttle missions have repaired, upgraded, and replaced systems on the telescope, including all 5 of the main instruments. The 5th mission was initially canceled on safety grounds following the Columbia disaster, 2003, but after NASA Administrator Michael D. Griffin approved it, the servicing mission was completed in 2009. Hubble completed 30 years of operation in April 2020 and is predicted to last until 2030 to 2040. Hubble is the visible light telescope in NASA's Great Observatories program. Other parts of the spectrum are covered by the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope, which covers the infrared bands. The mid-IR to visible band successor to the Hubble telescope is the James Webb Space Telescope, JWST, which was launched on December 25, 2021, with the Nancy Grace Roman Space Telescope due to follow in 2027. Once the Space Telescope project had been given the go-ahead, work on the program was divided among many institutions. Marshall Space Flight Center, MSFC, was given responsibility for the design, development, and construction of the telescope, while Goddard Space Flight Center was given overall control of the scientific instruments and ground control center for the mission. MSFC commissioned the optics company Perkin-Elmer to design and build the optical tube assembly, OTA, and fine guidance sensors for the space telescope. Lockheed was commissioned to construct and integrate the spacecraft in which the telescope would be housed. Optically, the HST is a Cassegrain reflector of Ritchie-Chrétien design, as are most large professional telescopes. This design, with 2 hyperbolic mirrors, is known for good imaging performance over a wide field of view, with the disadvantage that the mirrors have shapes that are hard to fabricate and test. The mirror and optical systems of the telescope determine the final performance, and they were designed to exacting specifications. Optical telescopes typically have mirrors polished to an accuracy of about 1/10 of the wavelength of visible light, but the space telescope was to be used for observations from the visible through the ultraviolet, shorter wavelengths, and was specified to be diffraction limited to take full advantage of the space environment. Therefore, its mirror needed to be polished to an accuracy of 10 nanometers, or about 1/65th of the wavelength of red light. On the long wavelength end, the OTA was not designed with optimum infrared performance in mind. For example, The mirrors are kept at stable and warm, about 15 degrees Celsius, temperatures by heaters. This limits Hubble's performance as an infrared telescope.